Hello again, ROS developers, and welcome to this ROS Project special on AI. If you want to learn anything about ROS, this is your channel. So you can learn about navigation, about drones, about autonomous cars, everything ROS related, you can find it here with videos of around 5 minutes to get some very concrete aspect of ROS or basic concepts, to courses of around 30 minutes or 45 minutes. So you can get loads of knowledge about ROS in our channel. Okay, we're back. So let's have a look at how we implement this my old moving cube environment. This is very important and is the cornerstone on how to use OpenAI basically. So let's have a look. So we need this guy here. Let's have a look. This one. Yeah, so let's put it here. This is the environment. So what do we need? As you can see, loads of imports to start with. Let's go step by step because it's quite dense. The first and most important concept on OpenAI Gym is this. Register. You have to register your environment. So the first thing, let's change this because we changed it to this name. So let's have a look. My old moving cube version 0. It has to be the same. So you remember the last video that we did this import and you said, why are we doing this if basically what we're doing here is gym make and tag? We're not importing any Python class whatsoever. Well, this is the magic. This does the magic. So when you do import, indirectly what you're doing is calling this register function, and it registers your environment in the gym database basically, and tells it to where to look for the classes, and there you have access to the classes. Yeah, you also give it the time step limit, which is 1000. Yeah, okay, this is a very important concept, and it's a source of errors when you're starting, so take care of this. So we define our old moving cube environment. Let's change the class, shall we? So my, yeah, and we'll put it here. Okay. So we have my old moving cube environment. So what do we need? So in a gym environment, you need some functions that have to be defined because they will be called from the environment object. So if you remember, we did, for example, this reset, so environment reset. Where is it defined? Because I say environment, I don't know which environment, just environment object reset. Well, it's defined here. There you go. But you see, it's underscore reset because what we're doing is we're using a virtual function defined in the gym infrastructure that's what we're calling here, but that one is overwritten by the one here that we define. So this is important to understand. Okay, so reset. So let's have a look. We have to do a class which inherits from gym environments. We have to initialize it, so define an init function, and here are loads of stuff. We're not going to talk about now this, just step by step and while we do it. So let's go to see this reset function. So here it's how we reset this simulation so that we have every time we start an episode, the robot is exactly in the same place and configurations, because otherwise it won't learn correctly and we can't iterate, which is like the basic stuff that you need for reinforcement learning. Basic at least. So what are we going to do? Well, we need to do loads of stuff due to Gazebo configurations and the controllers and so on. If you have any doubt about this, please leave it in the comments below, because it's quite dense why we do it. I'll try to explain it as best as I can. So here what we're doing is reset. The first thing we are doing is unpausing the simulation through this Gazebo object that we defined. Where do we define it? In the init method here, Gazebo connection. And this one is a method that we have to import. So let's have a look. This one, boom, and here. There we go. Okay, we have that one. Okay, fair enough. Then we do controllers object. Again, another object? Okay. Reset controllers. Okay, what's this? Well, this is defined again in the init function. When we initialize this class, this environment, we create this object, which is controllers connection, which comes from here, which comes from controllers connection. So let's go here, copy paste. There we go. And what does this exactly do? Well, this needs as input for initialization, we need the namespace of the robot, which is basically the namespace that you have in front of your controllers. And then the controllers list. So the controllers that you want to be resetted each time that we call the reset controllers. Okay. In this case, we only have two, because we have the joint state controllers and the inertial wheel roll joint, which is basically the one that controls the speed of the wheel. So it's very easy. In very complex robots like Fetch robot, like the NASA robot R2, it would be a very long list. Okay, and probably you would do a function which retrieves those controllers from the Gazebo server. Okay, but in this case, with a list is more than enough. Okay, so let's go again to the reset. We reset the controllers. Now what we are doing. Oh, very important. Why do we unpause it? Because for resetting controllers and for checking the sensors, we need the simulation to be running, because otherwise we don't have any sensory data and we don't have access to the controller reset functions, services. They won't work until you hit play. So it's very important that you do this. So check all sensors. What it does basically is check that all the sensors work. Okay. This is important in ROS, because sometimes they don't work immediately because you've resetted the simulation and maybe it's really difficult for the controller to restart. So bear that in mind. So how does this work? Well, we call check joint states ready and check autumn ready, which basically what they do is, for example, the joint states, the autumn works exactly the same. We wait, we are inside a while, and we try to do this. So ROS by wait for messages of this topic for 1 second. If you don't get response, then it will trigger an exception and it will say current moving blah blah blah, it's not ready yet, so let's retry again. And you try and try again each second. Okay, and you do the same with the autumn. So this guarantees that your sensory data channels are working perfectly. Okay, this is very important in ROS. Okay, so where were we? Yeah. So we check all the sensors are ready, and then we initialize the pose. So we initialize the robot. So we put, basically in this case, it's very simple, because we are just setting the speed to the init roll velocity, which in this case we could set any, but in this case it's set in our parent server, which, if you remember from last video, so we have here in this case is 0, which makes sense. You won't start with speed of 80, but it could be. So we have to do it like that. So once we have this, then we pause the simulation, yeah, and then we reset the simulation. So now resetting the simulation in Gazebo will make the robot go to exactly the starting position in which it was spawned in the first place. So good for that. Then we unpause. We reset the controllers again, just in case something moved, I don't know. And we check the sensors again. And at the end, we initialize the variables. So we initialize the variables for the class, which is the distance that we've moved, the distance that we've moved currently, so the total and the current distance moved, and then the roll turn speed, so the one that you set. So in this case is the init roll velocity. Fair enough. Then we go to here, and finally we get the observations. So the observations, and you say, hey, the simulation is paused. Yeah, but let's have a look. Get observations. How does this work? So get observations makes the retrieve of get orientation, blah, 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 get some from some inner functions. Those inner functions calculate different kinds of stuff for the observations. So for example, get orientation, it gets it from an internal variable which is self-autumn. Let's have a look. This variable, where does it go? Where is it generated? Well, it's generated inside here. So if we go here to the autumn callback, you see that each time that we receive a message, it's saved here. This means that when we pause, we have the most updated data. And this is very important to get the data coherent, because you pause the simulation, then you get all the data. So you won't have something that is like 1 or 2 milliseconds after or things like that. You have them all from the same timestamp. This is very important. Okay, and you say, how do we initialize all this? Well, you guessed it. So we initialize it inside the init function. So let's look here now a bit more in the detail. So here, basically, we're going to talk about this here. Okay, this is the part where we initialize all our subscribers and publishers. As you can see, when we initialize the class, we unpause the simulation, we reset the controllers, and we check that all the sensors are ready. And when they are ready, then we initialize the callbacks. Otherwise, we will have data that is not real. It's empty. So this is very important. Then we initialize the publisher, which is the one that moves the disk, basically, and then we check that it works. Because the same thing, we don't want to publish something that it doesn't move the robot, because otherwise the learning will start very badly. Okay, how do we do this with publishers? It's a bit different from subscribers. What we do is we check the connections. If there is more than one connection to this publisher, then we consider it good. Yeah, so basically that it's different from 0. And then if we go back again, I know that it may seem that I'm going back and forward, but I'm trying to explain it in a way, a natural way, so the way that you would develop it, not the way of like reading the code, because that's the way you would create an environment for your own robot. Okay, so here we go. So we check it and then we pause the simulation. Yeah, okay. So to the get observations. So get observations, what it does is we have to decide which observations we want to consider. We want to define the state of the robot. So in this case, I decided personally that the orientation, the roll, pitch, and yaw, it's important. I've converted to roll, pitch, and yaw because quaternions are really difficult to work with. And afterwards, if you want to validate a reward or if it's fallen or not, it's not that easy. So that way we have it, yeah? Then we calculate the distance that we've traveled in the y-axis, so in this axis. It doesn't matter if we travel here or here. The only important thing that we want to know is how much we've moved in this direction. It's the only thing that I care, to make the robot learn how to walk in this direction, in the y positive. Yeah. Then we get the current speed of the robot. This is obvious, we need it. Yeah, because this is the basic state of the robot that will define if we have to stop it and then make it move, or slow down the speed very, very slowly so that it doesn't move on the opposite direction. Yeah. And then the linear speed in the y-axis, the same. I want to validate that it's moving in this direction. Yeah. I don't care if it's moving in the x and the z. That's bad, so I don't care. Yeah. And basically I'll get it because it won't move as well. Yeah. So, but I mean, you can do it in different ways, and I would highly recommend you that you try to do something different. So you say in the comments, hey Miguel Angel, I think that this is wrong. I think that it would learn faster if you consider this instead of this. Fantastic. I would be delighted that someone wrote that. Okay? So go for it. Once you have this, we put it in an array, which is the cube observations, and we return it. And this is the get observations that we had in the recent function. Yeah. So once you get the observations, we do an extra step, which is, okay, inside these observations, which I use for many, many things, I want to simplify it, because sometimes for the QLearn, you don't need as much information, and you have to test that. So for that, we use the convert observations to state, which will be the final state of the robot. So in this case, we are going to get only the speed of the disk, the y linear speed, and the y angle. And with this, we more or less know that the cube is moving, it's moving like that. It's not moving like in the y-axis, but like moving diagonally. That's very bad, or not as good. And also how much we're turning the wheel. So basically that's good. Okay, and we consider, again, you can choose anything here. Yeah, okay. That's this reset. Oh. Okay. Good from here? Okay, let's continue. So now, this step is the one that it's taken here in the learning script. You have step, and this returns the observation, rewards, and done. And this is also a very important part. So the step is more or less the same as reset, but you don't have as many things for checking the sensors and so on, because in theory they should work by now if you execute step. So again, you unpause the simulation, you set the action, which means the action that they give you, you execute it, you convert it to a movement or something, and you execute it. Then you pause the simulation, and you get the observations that this action execution has generated. Yeah, and then with these observations, you say, hey, has it fallen? Is the episode done or not, based on the general observations? Yeah, and then once we have it, we generate a reward based on if the episode was done or not, and the observations. And once again, these observations are converted to a more simpler version, and these ones are the ones that are returned. Yeah. So let's talk about the functions that we don't know, which are set action, is done, and compute reward. So set action, let's have a look. Set action is this one. Okay, so action will give me, in this case, a number. So 0, 1, 2. The question is, which number? And how do I know that it goes from 0 to 4? And here comes, that's why I'm trying to explain it in a way that it's more natural. So in the init, the first thing we do is we fetch this parameter, which what it says is the number of actions, which is 5. Yeah, this is incorrect, so 5. And we set up this action space, and you say, where does this variable come from? Well, this variable comes from our parent class, which is a gym environment. And we set this action space with the number of actions, and we consider it discrete, which means 0, 1, 2, 3 numbers, discrete numbers, not continuous. Yeah? Okay. So let's go back again to our actions. So now we know that it goes from 0 to 4. And we convert these numbers, which are basically robot agnostic, to something related to our robot, which in this case is 0. I could put anything here, but I consider that it means that I set the speed to a fixed value. This means that it will change the speed abruptly. So it will go from 0 to 100, for example. In this case, roll speed fixed value, it's 100. So it can go from minus 100 to 100. This means it will jump. For example, it will move very, very fast. And it will respond, it will create an inertial response, a very big one. The 1 is the same thing, but okay, I'm seeing here an error, for example. Here it should be minus. Why? Because it's backwards. We need to do it backwards. Yeah? So we change from 100 to minus 100. Yeah? And he's saying here that he doesn't like this, well, because he's very picky. So we have to put this. Yep. So now, it's just slow here. So another action would be to be 0, to stop the speed. Good, that's good. Now, what more? Then we consider to increment or decrement. So plus and minus and increment value. So increments of 10 for each step. So yeah, it's okay. And once we have it, then we set this. We clip it because we don't want it, especially for the increments. We don't care, but this, we have to clip it between minus, so the minimum, and plus the fixed value. So in this case, minus 100 and 100, because we don't want it to go like 3,000 positive or 1 million negative. Okay, we have limitations, and it wouldn't make any sense. And finally, we execute the movement, which we talked about in the video before, so it's more or less the same. Just a little comment on this. So let's have a look. So here, what you see is that we are executing this speed. We publish it, nothing strange there, but we are waiting until the speed gets there. This is very important because that way, when you execute the action, the learning script won't go infinitely fast because it depends on a physical element, which is until I get to the speed, I won't do any action whatsoever because it won't make any sense. Okay, otherwise it will be changing all the time of speeds, and it won't move basically, or do very strange stuff. Yeah. Okay. So we were talking about the actions. Yeah. So next is, I think it was the reward. Yeah, compute reward. So in the compute reward, we have this, which it's very important. We get the observations and the done, and based on that, we say, okay, the robot is learning very well or is not learning at all. So in this case, we have this, which basically what we're doing is we're calculating this reward based on the reward distance, the y-axis speed, and the y-axis angle. Yeah, so we give our reward for the distance, more points. The y-axis speed, more y positive axis speed, the better. And y-axis angle, which is if it goes in this direction perfectly, good. If it turns to the right or to the left, that's bad. So we give it negative points for that. And we are using a sine wave for that, so that we give maximum negative points when it's completely perpendicular to the direction that it has to go. That's basically why we use the sine function. Yeah? Okay, fantastic. The last one. We can do it. Okay, so the last one is done. So if we go here, let's talk about this. So the is done basically gets the observations and say the pitch angle. So if it has turned, it has fallen basically. If it has fallen, then bad, which is the max pitch angle. We are getting it from here, from the param server again, and the pitch angle maximum is 0.2. So if it doesn't have to fall, just move a bit like to that angle, 0.2, and we stop the experiment because it wouldn't make any sense. Yeah, this is experimental because I've seen that if I put a bigger number, it just takes longer to see that it has fallen. Yeah, when it's 0.2, it falls all the time. Yeah, okay. So we have more or less talked about all the elements here, I think. We just comment on the seed, which is for the random stuff. So it's something that you have to put in your OpenAI environments. And I think it's quite it. I think so, yeah. So now comes the good part. So let's make it work. Okay, so what we are going to do is we're going to get this launch. And we're going to put it here. We're going to change the names of the packages inside. So here and here. Very good. The scripts are called same. Okay, I think, let me check. Okay. Yeah, fantastic. So let's have a look. So let me put this here. There you go. So source dev setup bash ROS profile. Okay, ROS launch my start there we go. Okay, so let's have a look how it's working. Let's put this like this, that way we can see both. Yeah, so you can see that it's trying very hard. There you go. Wow, that's good. You can see that each time that it like folds or something, it doesn't even get to fall. Just when it starts to move badly, then okay, yeah. Let's check on the rewards, just in case I missed something, or let me, I don't know. Okay, so the rewards, let me see the rewards. Let's see the speed. Okay, we're rewarding positive speed. Yeah, well, let's check. Wait. Yeah, the weight. So you can see that here we have the weight. Basically, we can change off. But yeah, we have it running. And each time that you see a red line is that we have reset it. There you go. And now it's trying to learn how to get it right. So we should leave it here, trying to learn this. And yeah, so now we would have to play with the parameters, with the rewards, and improve this learning, of course. Yeah, but as you can see, it worked. And as you can see also, it's quite complex because the environment, setting an environment like this is quite complex, especially because you're mixing stuff. You're mixing simulation, you're mixing so very basic and gym environment classes with simulation, with ROS, with the learning, with the rewards. So in the future, we're going to present a better system for this that will make your life much easier. I must tell you, okay? So that's it for today. In the description of the video, you'll find a complete course on OpenAI in Robotics Academy. So if you like the video, please leave a thumbs up and consider subscribing because we publish videos every day. And leave in the comments which project we should do next one, because this is the last video of this OpenAI with a Cube series. So it was fun to do it, and I would like some ideas, if you have some ideas on what we could do in the next project video series. So thank you very much, and see you in the next video. So bye.